Hello everyone, my name is Cole Nordmann and this is my presentation for the Online Academic Excellence Celebration. Today I will be presenting to you guys my senior seminar project in my field of computer science. And I have a presentation put together for you guys but that entails both PowerPoint presentation as well as some video walkthrough of what I've accomplished. So I hope you all enjoy it. I know I've enjoyed this project and learned a lot from it. So without further ado, here is my project, the Wizard's Tower.
The Wizard's Tower was born of an idea to make a artificially intelligent dice tower. And what this would be used for is it would be a dice tower in which you could roll a 20-sided die through the tower, and when the die comes out the bottom of the tower, a computer, in this case a Raspberry Pi, would be able to read an image of that die and tell you what number you had just rolled, and then it would be able to broadcast that number in any form possible. The construction of this dice tower really comes in three major components. Those three components are the tower itself, the dice tower, the hardware integration necessary to both launch the die through the tower as well as read the die once it's at the bottom of the tower, and then the artificial intelligence software that is capable of taking an image of a die and telling you whether it's a 1, a 2, or a 20, or any number in between. So the first thing that we'll talk about here is the dice tower portion. So the dice tower, if you aren't familiar, a dice tower is something like what you can see on screen here, in which you drop dice in the top, the dice will roll through the tower, and then they will roll into a tray at the bottom of the tower. It's really just kind of a fancy way of rolling dice in a sort of contained space that really only people like nerdy people like me who played tabletop board games and such have really even interacted with ever. But it is, in this sense, it is the medium through which my entire project, the environment through which my entire project would function. So for that, I didn't want to just go with any simple cardboard dice tower like what you see on screen. So instead, what I did is I went to the McKentry IT department and asked if I could use their 3D printer. And to the gracious souls that work down there, I was able to get access to it for this project. So I used a software called Tinkercad, or Tinker Computer Aided Design, and I designed my own dice tower. What you can see here on screen is the very first draft saved of that dice tower. In which I made it a circular dice tower that would be printed out of a plastic filament, where the dice would roll down the stairs in the center of it and out the door at the bottom. What you'll see now here is the actual final print design that went to the printer. This was done on the MakerBot printer in IT. Again, I want to thank IT, particularly shout out to George Chris for all of the help that he did with getting this thing 3D printed for the project. What you can see on the left there is the final design that was exported to the printer, and on the right is actually the printing, just the very beginning of the printing process itself. The next slide here, I have a few other images of the printing process of which took many attempts. There were many failed attempts that went into this, but we were learning a lot as we went along with the capabilities of a 3D printer and what we were possibly able to create. But as you will see later on, the final product was definitely worth all of the work that was put into this. So that is the dice tower aspect, and this is the creation of the environment or the medium through which the rest of the project will work. The next portion is the hardware aspect. So there are a few major hardware components that go into the creation of the Wizard's Tower, and primarily we'll focus on those four images on the right side. That is, there is on the top left there is a solenoid piston. On the bottom left there is a camera, just your basic webcam camera. On the bottom right there is a Raspberry Pi, and on the top right that is what we call a Pi Face Digital. Now to go through and explain those items. The solenoid piston is simply just a piston that when you send an electrical current through it, it will activate and push the piston outward. Um, the camera is just your regular everyday camera and is what we use to take images of the dice within the tower and transmit them to the computer so the computer can recognize them. The computer in this case is the Raspberry Pi, and the Pi-Face Digital is how all of these things kind of connect to one another. It is the connection hub, if you will. And what you can see, the image on the left, is kind of what all of those hardware components appear as once they are all put together and connected properly. Finally, we will talk about the software components. So the three major software components or software packages, if you will, that I used in the creation of this project are OpenCV, which stands for Open Computer Vision. This is a library that I used to actually do image manipulation and image capturing within the programming language. This is what allows the computer to actually see these images and do something with them. PyTorch is the artificial intelligence library that I was using for this project. PyTorch allows for some relatively um, simple creation of what are called neural networks, and I will talk about those a little bit more later on in the project. But that was primarily the brain of this artificial intelligence was created in PyTorch, and all of this was created using the programming language called Python. Um, and again, I will show off that a little bit more later. But with the combination of those three components, we do have the Wizard's Tower.
So this is the Wizard's Tower in all of its full, complete glory. As we can see here, I can point out these hardware components as were discussed in the PowerPoint. We have our camera up here on top, which focuses on the tray. That's to recognize and to read the dice that we roll through. This solenoid piston is on top of here, which launches our die, our 20-sided die, through the dice tower. And then back here, these are all connected through our Raspberry Pi, which is what captures that image and actually does the classification. I also have a small script here that activates this solenoid piston, and when I click run, it launches the die down and through the tower, and it comes out the bottom. All right, now that the die has successfully rolled through the tower, this is where the real fun begins. So, what you are seeing now is the code behind the artificial intelligence, or the brains of this whole operation. So first, we will see what the computer sees here by running this section. As we can see, this is the die that we just rolled through the tower, and it is sitting in the tray as a 19, and that is the die that we just rolled on the video a moment ago. So I'm going to go through now and explain some of the artificial intelligence practices put into place that allow this to recognize that die and then to classify it. And at the very end, we should see a classified die. What you see first here, there are the number of various libraries that were used that made this possible. This here is the OpenCV. CV2 is reference to the OpenCV, or Open Computer Vision, as was mentioned in the PowerPoint presentation. This here, this torch, and the various other torches are all reference to the PyTorch library that make this all possible, like was mentioned in the PowerPoint. This is all done in the programming language of Python. So this first major component that you can see here, this is our neural network, and these are the various layers of processing and computation that allow the computer to accept an image and convert it into numbers that it can understand, and then find some sort of some properties or elements of those images, of those numbers, that it can remember, that it can recognize, and then differentiate from picture to picture. These next few here, this forward pass is the major operator here. This is what allows me to take an image and pass it into our network up here, hence forward pass, and that's what allows us to get our actual our classification complete. These training and testing, these are both probably what I've used the most throughout this process is training. Is by definition, it is the method through which I feed the
the neural network information, or I feed it data, and it starts to learn. It starts to understand the differences between a 1, a 2, a 3, and a 4, and so on and so forth. And the test is the way that I can check that. I can check and see if what it's learning is correct. And then finally down here, these two bits, these two functions are a capture and a classify. And capture quite simply uses that CV2, that OpenCV library to access an image and then convert it into those numbers. It converts it into a frame and then sends it to our classification. And that's what actually pushes that image, that singular image, through our already trained neural network and then spits out an answer. And hopefully it's then the correct one. This last bit here is just the actual production of this entire the entire project. So what we see here is accessing my my GPU, or my graphics processing unit. That is simply to allow this to run faster than it would on a normal or a non-GPU enabled computer. And then finally it accesses our net, or our network, that I explained above, and then it captures and classifies the image. And if all things worked out correctly, and all of this is well, and our network is trained well enough, then we should be able to take that image of a 19, and when I capture and classify by clicking enter here, it will run through. It takes that image, it compresses it and puts it in a form that's a bit more readable, and then it makes a guess at what the number actually is. And as we can see right here, it says you rolled a 19. And it guessed correctly, so the network is at least smart enough to understand that number.
Okay, everyone, that is the Wizard's Tower. I thank you all so much for watching my presentation. I hope you enjoyed it. Thank you all also for making this academic excellence celebration still happen, even given all of the craziness that's been going on. If anyone has any questions about my project, I would love to answer any questions, either via email or whatever way that you can reach out to me in this time. But with that, I hope you all stay well, stay healthy, and thank you for watching.